Okay, what's up? What's up? Today you should be getting ready for your benchmark. You're the substitute today. I'm going to peek in right now, but I just want to start going over some practice test questions for y'all. So this one's asking here, what is the slope of the line? I'm going to still do right now 8 from the book, but I'm just giving some practice test questions, okay? 8 is next, okay? But right now let's just look at this question here. What is the slope of the line? So make sure you know this is in the form of y equals mx plus b. M is your slope, and slope is by the x, right? It's right by the x. This is your slope, okay? So what's that number right by the x? 12 is your slope. That's how easy this is. This right here, negative 19, is your y-intercept. This is your slope. Again, how do I know it's my slope? It's by the x, okay? That's how easy that one is. This one right here, a lot of people get this one wrong. Okay, I'm not going to read the question. I'm just looking at the answer choices. That tells me what to do. Oh, domain. Domain is your x values. So from here, all the way to here. Remember, these are my x values from here to here. I'm not looking at the y's. I could care less what the y's say. So x is between 0 and 230. Wrong, wrong. 6 is going up and down. I could care less. This is domain, your x values. Make sure you know that. So final answer is right here. Just FYI, your range is your y's, okay? Your range would be going up and down. Just FYI. It'd be from where? 6 to 36? It would be 6 to 36. This is your range. Cool. But that's not this question here. Next one. This one's super easy. I don't know what to tell you. This one's like a joke. Several ways of working this one out. You can distribute here. Oh, wait, not here. My bad. And solve for it. You can also that's one. That's option one. You can go ahead and second thing, plug these in right here. See which one works. And last way is the easiest, right? Menu 3, 1. It's called end solve. Okay, let me show you that one. 1.25x. Here you go. So you basically come out here to your calculator, turn on new assignment, right here, calculator. Okay, I forgot the equation now. 1.25x, 4x minus 10, 1 point. Oh, great, just completely blanked again. Jeez. No, 4x minus 10, 7.5. Okay, just double check that it's the same 4x minus 10, 7.5, 1.25. I think it's right. Okay. I totally forgot. You're supposed to come in here, go to menu 3, numeric solve, 3, 1 again. Let me show you that again. Menu 3, 1. And then you put that in there. 0.25 parentheses for x minus 10. I'll write it exactly over here, right? Parentheses equals 7.5. Looks good. And the final thing you say you want to solve for x. Enter. So the final answer is 4. Okay? So come over here. Final answer 4. Cool. Okay, so we'll come back to this test, move on. This is what we're doing right now. This is what we're doing right now. This is 8/7. Oh, this is actually 8/6. Super easy. Now, I want to tell you this much. You can do a million things in your head if you want to. All right? You can use the answer choices. You can factor it out. For this one here, this is the first way you should approach it. Factor out like this. You look at the factors of 54. Remember, there's a 1 here, so I'm not multiplying it yet. I don't do any of that, so I'm going to come out here, 1 and 54. But look, when I multiply these two, they give me a negative. Here it's positive. So here, these are going positive. 2 and 27. 3 and I think it's 18. Oh, these are positive, and these are negative. And guess what? There's my answer right there. See that one? So I go x minus 3, x plus 18. Minus 3 plus 18. I think it's that one for real. You guys got it? Cool. Second way of doing it. This is like, I don't know what to say, cheater's way or whatever way, lazy way, whatever. So that's the first way. That's why I would love for you to do it. If you don't like to do it like that, you can do it like this, okay? This is kind of like, look at this. You do 4, right? And I told you the first times first always gives you that. And the last times last gives you that. Now, just kind of, you have to do that each time. Checks out, checks out, checks out. So you're going to have to do FOR method all the way around to get these things to see if it's correct. That's method number 2. Just FOR all this out. You got it? Method number 3. This is the best method right here. This is, I don't want to say it's a cheater's method or what, but you should get this thing right here. Okay. Now what I'm going to do, look at this. The student mind showed me this. Basically, come here to the calculator, turn it on, go to graphs. See, this is a graph actually. X squared plus 15x minus 54. When you graph it, there's your graph. You guys got it? Now if I come out here and I go to tab, I can graph another graph. Remember we said this was the right answer right here? Okay, I'm going to show you a wrong answer. You see that right there? That one would be parentheses x plus 9 parentheses x minus 6. You see how they're not the same thing? So I'm going to go back to tab. I'm going to press up. That number 2, the red one, I'm going to delete it because that's not my answer. And I'm going to put the second one in there. That is my answer. We just figured it out right now. X plus 18. X plus 3. I'm going to put plus 3. It's minus 3. So I want to go back and fix that. Press tab. Press up. Minus 3. Now, you see how it's directly on top of the other one? Now you know they're the exact same thing. So it's like the cheater's way, but it's not cheating because you're using this to your advantage. You know this is a graph, this is a graph, this is a graph, this is a graph. That's also a graph. And they want you to know which is equivalent. Slash, 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 the same. Okay, then come back over here. Oh, this one's a joke. Once you see a table like this, look for the keyword rate of change. Rate of change, y'all should know it as your slope. Okay? So I'm going to go with these two right there. This is your x, the first thing you see. Second thing you see is your y. So 110, 324. 110, 324. So I would come to the calculator, turn it on, new document, don't save your old stuff, go to this in spreadsheets. Remember, it's 110, and then 324. Come over here, menu, 4, 1, 3. Come here, go to B, control right here, enter, enter. Okay, so it was asking for your rate of change, also known as your slope. Come back to my test. 7 is my answer. 7 is my answer. Rate of change. Slope. Okay. Let's go here. What is the equation of slope intercept formula that passes? Oh my gosh, this is a joke. Okay. So you saw that 1 just there right now. Menu 413. As you can tell, several times it's come out. Negative 4, 2. I'm going to show you something cool, right? Because I already have it here, I can just type over it. And it's going to change the answers to the one I want. Remember, that's the first point. What's that second point? Negative 4, 2, 12, 6. Negative 4, 2, 12, 6. And then 12, 6. There it is. Please look at this answer right here. This is going to be in the form of y equals mx plus b. Your m right here, and your b right here. So your equation is y is equal to 0.25x plus 3. Let's come back over here. Right there. Okay, so this one's super easy too. I would use my graph. You see this one? You can't graph that right there. You can't graph that one right there. You need to do some little trick to it. You got this, you divide by negative 5, divide by negative 5, divide by negative 5, and you go y is equal to 6 over 5 minus 3. Oh, don't forget the x right here. Graph this one out and look for it here. Okay? Now, I want to tell you this much. You should know how to do this already. This should be your m positive. So these two are out. These are negative slopes. You see this? This is m going to left. You should look at this one as a positive slope, negative slope. These right here are negative slopes. We have a positive slope here. This one's right here positive. This one's positive. Perfect. Look at my y-intercept. My y-intercept, my b, is a negative 3. So let me see. That's not a negative 3. That is a, oh, well, that even doing much. Okay, I'll come out here if you want. Graph it. Just add a new whole document. Don't be there messing around with that. The fraction was, oops, no, 5 over 6. X, don't forget, minus 3. Graph it, and there it is. You see it going through here. Now, if you go back to the handout right here, those are going in the left direction, out, or they're coming down, you can say. These are going through, you know, what you want, going up into the right. This one right here, boom, is a negative 3, positive 3, out. Okay? I'm going to get ready to go. We'll do some work together right now. Okay, finally, guys, we came to the difference of squares. Now, this is very sneaky. This one just comes out of random places. I've forgotten about this one, too. Like, once in a while, it's like, what? Where does this stuff come from? So if you think about the word, it's called difference of squares because it's the difference slash their subtraction. You got it? Of squares. What do you mean of squares? Like x squared minus 9 squared, or 9. You got that? Isn't that a difference of squares? That's not a square. Yes, it is. That's 3 squared. You can have x squared minus y squared. So that's basically it. It's pretty easy. It's not too bad. So when it comes to this, when you figure out, you see a factor. I'm sorry. You see something squared minus something else squared slash a difference of squares. This is what happens. It's pretty cool. It basically breaks down like this. You see this? It becomes 2 parentheses. This one is what squared, so it goes here and here. This one is what squared, so it goes here and here. Like I was saying right now, if we had x squared minus 9 squared, or 9. That one breaks down to this right here. X and x, because this is an x squared, so it's an x and x. And this one here is a plus 3 minus 3. do this. Pretty cool, guys. It's actually, man, it's just like, well, it's an easy joke. Jokester. I like the parents play jokes on you, and it's so easy. Okay? So let's just go out here and practice some of this. Now, this one's kind of way out there. What is that? Something squared. Actually, that is. You see that right there is 4h squared. What's that one squared? That's 3a squared. Okay? So when you see this, this is honestly a difference of squares. It breaks down to this. Put a plus, put a minus. What is this one here? What squared means what times itself to give me 16. 4 times a 4. Okay? H here, H here. This one, what times itself gives me a 9. A 3, 3. And I'll put an A here and an A here. And there it is. That's it. Going once, going twice? Not too bad, is it? It's a joke, honestly. You gotta kind of, you have to be aware of it. You have to be able to catch it. If you don't catch it, you're like, oh, what are they trying to explain here? Or what are they trying to make me do? Yeah, if you don't catch it, it becomes like a weird thing. Like, what in the world? So now look at this one. Is this one a difference of squares? Well, I'll tell you this part. This first part is 11 squared, right? It gives you that 121. This one here is c squared. You got it? And then we get this and square it. What? Well, let's think about this. 11, ready? Times 11. Right? It gives me 121. Multiply these two, which gives me c to the 4th. Isn't this that? So that's a square. Is this one a square? You got to think about that. Is that a square right there? I won't tell you this much. The book does it, and it tells you it is. Think about this. Yes, 5 is something. I mean, 25 is 5 squared to give it a 25. The d here is not d squared because it will give you 4. Basically, you see this one? How it's to an odd power? You can't ever have something squared for it to be odd because you can always multiply it times a 2. So that one, if it's an odd number, it can't be a difference of squares. So that one is not. Okay? Let's try some of these real quick. Okay, so 1a. 81 minus c squared. Is this a difference of squares? Yes. You know what this is? This is 9 squared minus c squared. Doesn't that make sense? So you would break it down like this. 9 plus, 9 minus, c, and c. 1b up here, I have room for it here. So that one is actually 36 is really what, 6 squared? 6n, all of that squared. Minus, shoot. No, right? What times itself would give me a 27? Nope, not a difference of squares. 1c. 25y squared plus. What? This is not even a difference. Nope. D, let's see this one. This one here, if you look at that, is 8g squared minus h squared. If you want to see it like this, let's see it like that. It has to be actually like that. Okay. Now let's see what happens here. Well, because it's a difference of squares, a square, guys, I actually mean a square. It has to be a square. It goes like this. Plus, minus. I'm more sure some of y'all are asking yourself right now, why in the world does it happen like this? Why is there no middle term? So we're telling you this is the answer. I'm going to show you what this is and how it becomes this one here. Ready? This times this. 8g squared. Check first term. That's here to here. Next thing from here to here. Multiply those two together, you're going to give us a negative 8GH. Cool. Next thing multiply is this right here, and that gives us a positive 8GH. Well, what's the deal with these two? They cancel out. Last thing is here. Slash leaving us. Whoa, I forgot this one right here. 8G times 8G is 64, guys. My bad, I don't know what I'm doing. Leaves us with a difference. You see that difference? It leaves us with 64G squared minus H squared. Leaves us with a difference of squares. Cool? Okay, so I'm going to kind of wrap it up pretty soon. Let's look at this one real quick. What happens if it's a factor, all right? It's a difference of squares, and it's factored to these two things. And then you see how this one breaks out to a b squared squared? And this is a 4 squared. So it becomes like this b squared plus 4 and b squared minus 4. Look at this, very sneaky. This one right here is still a difference of squares. So that one breaks up into this, which now breaks up into this. So this difference of squares breaks up into all of this right here. Is that pretty cool or what? Yes, you're welcome. Okay. Let's look at this next one real quick. So if you didn't know, this one was 25 squared, okay? So now this is a difference of squares, difference, something squared and something squared. Breaks up into this right here. See, this is 25 squared, becomes 25. This one's x squared squared, so it becomes x squared and x squared. Now, in this situation, look at this one. This is also a squared. All right, a 5 squared. This is still squared. So we're going to go break that. This one alone becomes this right here. 5 squared minus x squared, just rewrote them. Becomes a 5 and a 5. I always go plus minus. So this is not a difference of squares. So this one actually just keeps on coming down, right? Just keeps on coming down with it. So finally, this thing becomes these three. Let's check it out. Let's do one or two of them together. We'll do two. We'll do two and we'll call it not quits, but we're going to go try another kind. So right here, we're going to have y to the fourth minus 1. Is that a difference of squares? Yes. This right here is y squared minus, this is 1 squared. Do you agree? So this one here becomes y squared plus 1 and y squared minus 1. Not a difference of squares. This still is a difference of squares. So y squared minus 1 squared. So this part, which is this part, which now keep on coming down, becomes y plus 1, y minus 1. Just this part. Bring this part down from the beginning, and we'll have y squared. Cool. All right. Let's go. Let's jump down to this one over here. Now, look at this one. Is that a difference of, is that a difference of squares? No, it isn't. I'm not going to, for these to be on your test, you'll get one of these questions. You're not going to get a lot. But I want to tell you this much. Just in case you forget, and it's asking you which of these is equivalent, you can always multiply this stuff out. And if it equals that, or you can still graph them. I'm going to tell you like a cheat way. Change all the g's to x's and graph it. And that's it. Okay, graph this one, and then graph this one, and you can see they have the same graph. Okay, so let me come back here and tell you this one. Can't I factor something out of both of these? I can factor out a 3g. When I factor out a 3g here, it becomes 9g squared, and then this becomes a 1. Difference of squares. This is a 3g squared minus a 1 squared. This becomes 3g right here. I always go plus minus 1, 1. There it is. Final answer right there. Let's try two of these, and then we'll move on, okay? Oh, wow, look at this one. When there's 4 of them, break them down to pairs. This one factors that out. This one factors this one out. So now factor out this part here. You're left with an x squared minus 1 slash a difference of squares. So factor those two ones. Oh, this is a real good question. Okay, let's look at this one real quick, okay? We'll do 2a and 2b. So what it's trying to tell you to do or be aware of is be aware that you might have some stuff you can factor out first. What could I factor out here? I could factor out 2. And I'd be left with y to the 4th minus 25. Oh, look at this. A difference of squares. This part here is y squared minus 5 squared. Difference of squares, guys. 2 on the outside, don't forget that. So this part here, it breaks down to y squared plus 5 and a y squared minus 5 with a 2 on the outside. And there it is. This is that thing factored. Let's do 3c down here. Okay, 2m cubed plus m squared minus 50m minus 25. Okay, so what it says to do is group them, and you know that. Every time there's like 5, group them. Factor out here, I'll factor out an m, which gives me 2m squared plus, I can factor out an m squared plus 1, 2m plus 1. Now, I really want 2m plus 1 here. So what could I factor out here? A whole 25. But the positive does not give me a negative, so this one's going to be a negative. And I think that works. Yeah, it works. So now look at this here. Here, factor that out. 2m plus 1. We're going to go with m squared minus 25. Once again, try. What do y'all think of that one? So, más o menos. It's not too bad, but it's doable, right? And I think we're going to stop there, guys. You do have an assignment right now, Alex? Okay. We're going to call this one 8-7. Whoa. 8-8. And we'll call it 8-7. 8-8/review.